Oh my god, an 87.
Alright. Is there anything on last night's homework? Yep.
Okay, wait. So when you're on number 7, you're given the
Can you
graph.
guys stop talking? Yep.
So yesterday in the beginning we talked about just 1 and 2 times it goes
Yeah,
through,
correct.
but then we continued to talk about 3 and 4.
And 5 and 6
Yeah.
and 100.
How on like when it goes through -5, I don't know, instead of 1 it's like 3. Like
Because you know for sure, on this one you have more info, right? So you know for sure that because it's tangent here,
yeah.
that it has a multiplicity that's even, correct?
Yes.
So the least it can be is 2.
Yes.
That's very small.
So we're just writing like the ones we know for sure.
Well, hang on.
Okay.
So the least you know, the smallest this can be is 2. The smallest this can be is 2.
Yes.
The smallest that can be is 1.
Yep.
That can be is 1, 1, and 1, correct?
Uh-huh.
Okay, well let's add those up. That means there's 1, 2, 3, 4, 5, 6, 7, 8 solutions if I take the minimum. Correct?
Because the multiplicity equals the solution.
Correct.
Okay.
The multiplicity means that that solution happened twice. It was just the same solution twice.
Okay.
So there's 8 solutions here right now. That's the smallest possible solutions that I could have.
Okay.
Is 8. And they told me it has to be an 8th degree
Right.
polynomial. So in this one we know for sure because of that.
Okay.
Okay? Yep.
If this was like a 7th degree, would, like, for -15, would you make it like multiplicity of 3, not 1? To get the total of 10?
Possibly. Like whichever one flattens out more. Yep. Anything else? That's assuming they're all real. Yep.
Or they could do it multiple entries.
Not for this one.
Not in this one.
But in like,
It's like.
but like in this one down here, we couldn't be as specific because they didn't really give us enough information to be that specific. Like, you might be able to argue that this definitely doesn't bend; it goes straight through, right? So that you're pretty confident that's 1 multiplicity of 1, that's multiplicity of 1, that's multiplicity of 1. But you don't know whether this is how flattened out does it need to be. So all you know about this for sure, 100% sure, is that this is going to be an even multiplicity, okay? And that these are going to be odd multiplicities, if you want to be like, matter of fact, for sure, 100%, okay? Yep.
How do you, like, I don't understand how you know, like, on the other one, like the one above it. Like, I understand how to tell if, I can tell if it's 1 or, like, more than 1, but I can't, how do you know if who's like the whole?
Because that's what we were talking about yesterday. If at the root it turns around, it is tangent at that root, it has to be an even multiplicity. That means the root repeated, for sure. Okay? But either repeated twice, 4 times, 6 times, 8 times, an even amount of times it repeated. That's what that means, when it turns around and doesn't cut through.
How do you know it's like not 4
Because the smallest it could be is 2, correct? And the smallest that could be is 1, because it cuts through. So there's 1, let's assume the smallest. X equals -15 is a root, correct? And we're assuming that it goes straight through and it's a multiplicity of 1, right? Here, it's got to happen at least twice, so let's take the smallest. So we know x equals -10 happened 2 times. On the graph, it's just one spot, right? X equals -5, we're assuming happened once, as it cut through. Not 3 times, not 5 times, right? 0. Once, this one, twice. So minimum twice, once, twice, once. So the smallest possible degree this could possibly be is 1, 2, 3, 4, 5, 6, 7, 8. That's the absolute smallest. Could this be a 4 and that be a 4? Maybe, but no, it can't, because the direction said it had to be 8th degree. So now I can't do anything else. That is the only possibility. If they didn't tell me it was eighth degree, then I don't know. That's what we're saying. I would need more info.
Yeah.
Okay? Anything else on this? Yep. Find two different polynomial functions with those zeros. They all have a multiplicity of 1. So, working backwards off your zeros, you were good with like it's x minus 1 times x minus 3 times x minus 5. From there, what we've talked about in the past is you can have a parabola. Let's just talk past here for a minute. Midterm review. You have a parabola. It crosses at 2 points, right? Whatever the equation of that parabola is. I could also come up with an equation of a parabola that has the exact same roots, so maybe it's negative, right? I could come up with one that's just stretched out way more, okay? But has the exact same roots, right? We're talking vertical stretching right now, that transformation stuff, okay, that we did early on. So how do we deal with that? Basically, it just means you could multiply by any number right here. Make it a 2, make it a negative 2, make it a 100, make it 1,000, make it whatever. And no matter what I throw here, think about it. If you went to solve this, and I threw a 2 in front of this, what's the very first thing you do when you were solving? Would you divide by 2 and get rid of it? Aren't I left with the exact same thing? So then, whatever I put out in front of it, it's a constant. As long as I don't put an x next to it, you put an x next to it, now you've added an extra root. Okay, but any number there that's a constant next to it, it changes the equation. Like stretch it out, but it's going to have the same exact roots with the same number of multiplicities. Okay? What else? 'Cause we're going to use this today again. You got to understand that. Yep.
Your function just be y equals x minus 1, x minus 3, x minus 5. Like
Yes.
you have it too?
That was the one, probably the first one I would have given. And then I just picked the number after that. What some people wanted to do, what they wanted to like distribute across all of this, you're going to mess up somewhere if you try to do that. Like on this one you would have been okay, because they're all multiplicities of 1, but you don't really understand that. So then you're going to start trying to do it with squares and cubes, so just leave it alone. Just put the a out front. All you need. Okay? Yep.
On the one after, I like know what to
Wait, the one after like next page or 6?
No, sis.
Yeah.
So like I have x plus 4,
So y equals.
y equals x plus 4 to the third,
Yeah.
and x minus 2 to the fifth. Can you put those right next to each other?
You have to.
It looks really weird.
Sorry. Those yep, they're all multiplied together.
And then when I put like, I did say, I multiplied it all by 6, but I put like brackets. Where did I just put 6 in front?
6.
Then, okay.
What I don't want you to do, this is what I was just talking about,
It's
is
distributed.
you're not distributing.
Yeah, I hear that.
Because PEMDAS says I would have to do all of this first before I was allowed to distribute.
How would you show then if you wanted something just multiplied by the first thing? The first. X plus 4.
It's not just multiplied by
I know, but like, if I wanted to.
I don't know what you mean by that. I guess if you really wanted to do something, I'm gonna just take a wild guess as to what you might want to do. Okay.
I'm so confused now.
Does that not mean the same thing as this?
Yes, it does.
Is that really what you want to do?
No.
What do you want to do?
Yes. So then, in that situation, the 6 wouldn't go to the x. It still would.
It would go to the x, but it wouldn't go to these. And
Okay.
that's why you can't do it here.
Okay.
Because it's not going to these, it's only going to that.
Alright.
That's what I'm saying. That's why you
Okay,
can't
yeah.
distribute here.
Yeah.
And dots. You gotta do this first.
Okay.
Okay?
Mm-hmm.
What else? We're good? Okay. Final day, put all the pieces together for your test. I guarantee you're not the only person who doesn't know that, by the way.
Well, no, I
You're
like.
just brave enough to ask.
Yeah. I had the answers right. I don't really know what.
Alright.
Yeah.
So listen. They want us to determine the equation of this quadratic function who has roots at negative 3 and 4 and passes through the point 2, negative 5. The final answer is supposed to be in standard form. We're going to come off the graph first. So honestly, this is review. We did 2 units on quadratics, correct? So the fact that they're telling us this is a quadratic, what do you know about my graph? It's going to be a what? Parabola. I already know it's going to be a parabola. These are things I already know. I know the roots are negative 3 and 4. Where do they go in my graph? Midterm in a week and a half. Where do they go in my graph? X-intercept. 1, 2, 3. 1, 2, 3, 4. Okay? I also know that 2, negative 50 is a solution to this equation I'm supposed to come up with, correct? So, two negative 50 is also on that graph. What else do I now know about this parabola? Yeah? Negative 2, negative 50, negative 2, negative 50? No. Yeah? It opens up. Would you guys agree with that? Could it possibly go like this and still hit that point? No. So we do know it opens up, correct? Opens up, which means we know what about this equation that we're getting ready to write? What is a value going to be positive? Okay, so we know it goes something like that, right? What else can I find real quickly by looking at the graph then? Again, midterm in a week and a half. What else do I know about this graph that I can figure out? It's a parabola. The y-intercept is going to be negative. I like it. Do you guys agree with him? Okay, what can we find? Axis of symmetry then, right? How does he know the y-intercept is going to be negative? Because it has to go like this somehow, right? And then come back up. It's going to have to hit that. Can't hit it down here. Can't hit it up here. Do we agree with that? So we know y-intercept is going to be negative. We should be able to find the axis of symmetry, correct? So, I'm getting a little nervous. Getting a little nervous here. Well, I don't have an equation anyway, so you really need to know what the magical equation is that's going to find this axis of symmetry since you don't know what the equation of the... No! You need to go look at the graph and find it. Go, find it. What is the axis of symmetry? What does symmetry mean? Should be symmetrical. Where's the magic line that's going to make this symmetrical? What's it going to be? Well, it can't be 0, comma something. It's not a point. It's a line.
The y equals 1.
It's not going to be y equals 1. Okay, freeze. Do you have an answer? Come on, big. Okay, so tell me what the magical symmetric line is. 0.5. X equals 0.5. How did he magically make that occur?
Oh,
It's the middle of the roots, right? Don't they have to be balanced on both sides if they're both sitting on the x-axis? Many of us need to bond over the next week and a half. All right, so I know what now? I know that my turning point is somewhere along here. Do you guys agree with that? Can I now find the point that's symmetric with this one? Julie was trying to get us there. She was just a little off, right? Can I now find my symmetry to that? How far over do I need to go? 1.5, so a half and 1 more. Down at -1. A little bit far now. Good? Well, probably because my dash is... That's 1.5 and half and 1. Okay? It's just probably the way the grid is. Okay. We got that. Alright, that's pretty good. So we wouldn't know, we don't know where our vertex is, but we'd have a pretty good sketch here already, right? Put it around here. Okay. So now let's go find the equation of this sketch that we got. Which again, we didn't need the equation, we had enough information to get all that down, correct? That's what you need to be able to do. Okay? So now, how can we write the actual equation so we can type it in our graphic calculator, check to see if we're even on the right track here, if this is what it really looks like, if we're right, back ourselves up. Okay. Undo the roots. Okay, what do you mean by undo the roots?
Y equals X plus 3. Or X minus 3.
We're good?
No.
So you gotta.
A.
Oh, true, I'd have to do that in a minute, but let's just type this in and see if we're there. Let's type it in.
Yeah, you need an A value.
Okay, let's check this one out first.
I'm just guessing.
You don't have to. Same thing, they're both the same equation. Yeah. Yeah, we
The
really
same
did already do
problem?
this.
Wait, why are we doing it?
Because the quadratic's a polynomial. Not gonna make it
Then
different.
what's all this up to?
We're getting there, keep going, it's all the same thing. Type it in. Check your table. How are we looking? Is negative 3 a 0? Is 4 a 0? Yes, we're feeling good about that. Is 2 negative 50 on this graph? No, not on this graph. Why? This is the stuff we talked about before. Isn't this the same stuff we did last night for homework? Yeah, what do you got, Grace? That's one vert, right? So clearly A is not 1, right? And you need to figure out what it is that that magic number was that they multiplied by, right? So this is not the right equation to meet all requirements, right? So y equals A times x plus 3 times x minus 4. How are we going to figure out what A is? Yeah?
You plug in the formula.
Well, it's gonna be positive.
We know that. We should get a positive answer, Luke.
You plug in the -50 and
The solutions, right? You know this is the solution that wasn't on your original, correct? So fill it in. So negative 50 equals A times, I fill in 2 for x. So this is where people are getting all freaked out before they wanted me to double distribute because they were like, felt like they had to do that. But does it really matter if I fill in x when it's in this format? No, it's actually a little bit easier to do, isn't it? Like in your head. Because now you go do the parentheses. And what do you really have? A times what? 5 times what? Negative 2. Multiply, what do I got? Negative 10a. Everybody with me? It's actually a little bit easier in this format than to try to do it all out and then have to square it and all that. So then a is equal to 5. So then the equation to my graph over here should be y equals 5 x plus 3 times x minus 4. So if you put that in your graphing calculator, do you get your -2, negative 50 as a point and get your zeros as points? Yes. Now, here's the only issue. The direction said you have to have your answer in standard form. Okay? And this is not a standard form. So if the direction said just give me an equation, you can be done, right, and move on. But it says that it wants you to put it in standard form. Okay, so that's just a matter of you doing algebra, correct? So here it is. Okay, my suggestion, you can distribute this 5 first if you want. Okay, but it only goes with that parenthesis. I would just deal with these 2 first and distribute my 5 at the end, personally.
We only go with the first one.
It does. It doesn't get to be shared with everything, right? So y equals 5 times what? What's the answer to this? X squared minus x minus 12. I'm hoping we get to a point now where we're doing enough algebra to do that in our head. And then what? Distribute your 5.
5 Why would you do that?
That will be no.
5 was already taken
That's
out.
what the original equation is without the 5.
This is in standard form. This is in standard form. Alright, we good there? Questions? Okay. Alright. Also, something else that's nice about these equations as we move on. So, what does it look like? It looks like our y-intercept definitely below -50. We agree with that? Okay, so how could I find it quickly? Let's say, I don't have to get to here to find the y-intercept. Right, I know you can see it here, but couldn't I just fill in 0 here and 0 here and then just multiply quickly? Just kind of see what we're doing there? Same thing we did here, we just filled in the 2's there quickly. Okay, so it's kind of nice to leave it in that factored format, yep? No, I'm not looking for the turning point, I'm looking for the y-intercept.
Oh, okay.
Yep. But otherwise, yes. There's a couple of other ones. Alright, questions there? Alright, so now we go down here. This is also review. What are your x-intercepts for this parabola? -2, +5, right? They wanted you to sketch this graph. Okay, what things do I know about this graph? So the roots are at -2, +5. Know that. It's a parabola. Opens up or opens down? Opens up. What would be the lead coefficient? What number? +1, right? Okay, so it opens up. Could I quickly find the axis of symmetry? Yes, what's it gonna be? 1.5? Okay, 1, 2, 3, 4, 5, 6, 7, so 3.5. Okay, so we're sitting at 1.5. Y-intercept. So again, this is what I was talking about. So for the y-intercept, do I actually have to double distribute this to find the y-intercept? No. If I want to find the y-intercept, what do I care about? I care about when x equals 0, right? So I want to know, fill in 0, right? What's it going to be? -10, right? Okay, so y equals -10. All right, let's see. There's -10, and then 1.5 away again. -10. How could I quickly find the turning point? How could I quickly find the turning point? No, I don't have a turning point. I have the axis of symmetry. Yeah, that's what you were just asking me about, right? Plug in 1.5 instead of 0, correct? There is, yes, but yeah, but you gotta put this in the standard form. What is the formula to find the axis of symmetry? X equals, what's going to be premature? -b over 2a, right? But then it's got to be standard form so you can find out what b is and all that. Okay? So we don't need any of that though because we can do it here because we already know what the axis of symmetry is. So y equals 1.5 plus 2 times 1.5 minus 5. (3.5) times -3.5. Right. What do we get? -12.25. So on my line down okay. So sketch, rough sketch. Actually, it's pretty accurate sketch. Yep. The turning point. I filled in 1.5, which is the x-axis. The turning point is somewhere along here, right? Just don't know where, so I gotta plug it in so I can find out where the y is that goes with it. Plugged it in for x. Right? Doesn't matter what format it's in, I just gotta fill in for x, right? Okay. So look, what happens here on this one? Think about it for a second. If I want to find, are the roots any different?
No.
No. So the roots are still sitting here, right? What's your y-intercept gonna be on this one? What do I do to find the y-intercept? Plug in 0 here, plug in 0 here. What do you get here? Still negative 10, but then what do you do with that? Multiply it by 2, correct? Okay, so now I'm down at negative 20. My symmetry is the same. What about my turning point? Do I really need to plug in 1.5 here and 1.5 here to figure out what it's going to be? Don't you just multiply it? You're going to get the same value again, and then you're going to do what with it? Multiply it by 2, right? This is your vertical stretches. Remember transformations? Vertical stretches. So negative 12.25 becomes negative 24.5, right? 24.5, somewhere around there. So this is y equals 2, x plus 2, times x minus 5. So what's going to happen to the next one? Are the roots going to change? No. Roots are still the same. What about my y-intercept?
Times 4.
Times 4, right? Which one times 4? The first one, right? Times 4. You're down at negative 40. And then what? What is going to be your bottom? 49. There's your stretch that we talked about early on. I believe. Questions on that? You think we're still good? Okay. All right, so now create the equation of a cubic in standard form that has x-intercepts at negative 4, 2, and 5 and passes to the point 620, verify your info. We're going to go reverse. We're going to sketch first. Take our information and figure out what we know, right? So I know that negative 4, 2, and 5 are solutions, correct? Solutions where? On the x-axis. So 1, 2, 3, 4. I got negative 2. I got positive 2, 5. Right? What else do I know about this? It's important that they told me up in the directions. Yep. That it was cubic. That's important. What does cubic mean? It's a degree of 3. So I know it's a degree 3. Which means what for me? Tell me other stuff that I now therefore know. Yeah? It's low to high or high to low. So I know end behavior. That's the vocab I need. End behavior is low to high or high to low. That I know for sure. Not sure which one. Yeah. So there's 3 real solutions, right? We know that we've got all 3 real solutions, correct? There are no other solutions. We're good there. What else do we know that they gave us? Yeah? 620 has to be on my graph. All right, so this is not supposed to be negative 5. This is supposed to be negative or positive 100. That would help. All right, so what do I got? 620. Okay, how does that help?
You have to find this.
What? How do I know it goes low to high? Right, so because it's got to go like this, correct? And is it allowed to turn back around and come back down? No, because all the zeros are covered. So what does that mean about over here? Had to have started low and finished high, correct? So we now know that it's low to high based off that last point, 620, right? That's for sure. We know that. So we already know, without doing much, we know it's gonna look something like this. Come up through, somewhere it's gonna turn around, cross the positive y-axis, come back down, go through it 2, turn back around and come back up, correct? So it's gonna look something like that. You guys agree? And we haven't really done much, correct? Okay? Alright, so now how can we write the equation of this so we get a better look at it? What do we got for an equation? Yeah.
Well, would that A value be negative? Because-
Okay, what would the A value be? I don't think you want negative here.
No,
It's low to high. Positive your A value should be.
Yeah.
When you find your A value, you know if you've done it correctly and when you find your equation, if you don't get a positive A value, we got issues because it's not matching up with what we were thinking through. Okay? So y equals what? X plus 4, x minus 2, x minus 5. Not exactly. What are we missing? A. Because we don't know what the A is 1, correct? Alright, so now what? 20, use my solution, right? So 20 equals A, 6 plus 4, 6 minus 2, 6 minus 5, A times n times 4 times 1. So 40A. Are we okay with that? Which means A equals a half. How's our algebra? I can't close algebra. Arithmetic. How's our arithmetic? We're good? Okay. So now we got our A value. Okay, so our equation looks like this. Y equals 1/2 x plus 4 times x minus 2 times x minus 5. I want to be able to sketch this a little bit better. Can I find my y-intercept very quickly? Okay, let's find it. What's my y-intercept quickly? 7 and 0, right? So you really have 1/2 times 4 times negative 2 times negative 5, right? So what do we got? Negative 20? That's positive 10, right?
I'm
So
getting
po-
negative
definitely going to
3.
be positive. It's up here, right? So that's 10, that's 40. Half of that is 20, right? So positive 20. So 0, 20. Somewhere around there. Alright, so I probably need to start my endpoints up a little better here. So I'm thinking, if I try to do this smoothly, it's probably not going to curve right over to that y-intercept, correct? Okay, it's probably going to do something more like maybe, it goes pretty decent flow, maybe a little bit. Something like that, I would assume. Alright, can we go type this in our graphic calculator to make sure all our points are on there? Yep.
When you get your equation, and you just plug in the y-intercept,
You like store for x, I think, store 0 for x. Or you can plug it in. Oh, put it in and then, yeah, and look at the table? Sure. Unless it's the no calculated part of your test. Like really not that much arithmetic.
I don't think it did it.
It did what?
No.
Are we good? Are those points on there? 620 on there, negative 40. Hello? We checking? We're good? Okay. Now, here's the only issue, correct? What did they say? I gotta follow directions. They didn't just want an equation, they wanted it in what? Standard form. So now we're just gonna check and see how good your algebra is. Alright? So here goes. I'm like out of room, so what am I doing? Okay. I'll start down here, I guess. So here's the deal. Me, personally, I'm not gonna distribute this 1/2 right now because I don't want to deal with the fraction throughout this entire thing. Okay? So what I'm gonna do is I'm gonna take 2 parentheses at a time. I'm gonna do the last 2, only because I know what my next step is, but it doesn't really matter. Okay? So I'm not gonna touch this 1/2. I'm not gonna touch the x plus 4 right now. Can we quickly do this in our heads? What do we got? X squared minus 7x plus 10. If you can't, then write it out. Okay? So that's these two put together, right? These are still equivalent. What would I need to do next? I still don't want to deal with this 1/2, right? I'm going to take care of that in. What do I have to do? Double distribute here. Right? That's why I left the 2 out here rather than doing 3 of them across. Okay, so y equals 1/2. Now, I still need a parenthesis here because this 1/2 isn't just going to get multiplied by the first term. It's going to go all the way through at the end, right? So x times x squared is x cubed. X times 7x minus 7x squared. X times 10 plus 10x. 4 times x squared, positive 4x squared. 4 times negative 7 minus 28x. 4 and 10, 40. I did it that way just because I knew I was, it doesn't matter. If you have the 3 first, then you gotta distribute the 3 twice. Right. It's not gonna matter. I just think it's easier that way.
Wait, how did you know though?
Because there was 3 of them and then the next step was to distribute again. There were 3 parentheses.
So why'd you do that?
Because I just only wanted to have to distribute the 2 of these rather than, it's not gonna matter. If I have 3 here, then I have to take go twice the other direction.
Okay.
Doesn't matter.
Yeah.
Alright, so then, I'm coming up here. Okay, so I could distribute this 1/2 right now, but what would be better? You have to like terms together first, right? So y equals 1/2, like terms, x cubed minus 3x squared minus 18x plus 40. Am I good there? And then distribute your 1/2. Y equals 1/2 x cubed minus 3/2 x minus 9x plus 20 squared. Thank you. So if you put this in your graphing calculator, you should get the exact same table as you got with that other one, right? Because they're
May I
equivalent.
have your attention,
The
please?
same thing in a different
Boys
format.
varsity swimming has been canceled for today. Thank you.
How are we doing there? Good? Alright, so let's come down here and look at the graph. We want to create the equation at the end. What do they tell us? They tell us we have a root that's at -2, right? Okay, so I go over here to -2. And I have another 0 at 4. Right? Right. So this is key. That means you have a multiplicity of 2. And what else do they tell me that's important? It's cubic, again, right? So it's a degree 3, which means it either goes high to low or low to high, right? They also tell me the y-intercept is sitting at 0,16, correct? Somewhere around there. Okay, so think for a second. I should be able to tell based off this information whether it's high to low or low to high. Either high to low or low to high. Which one? High to low. It has to be high to low. Why does it have to be high to low? If it started low, what do I know has to happen at -2? It's got to be tangent, because of multiplicity, right? So if it happened down here and I turned around down here, wouldn't it have to be a y-intercept down there? Like, you'd never cross this point. You guys agree with that? And then you wouldn't be able to do it. So the only possibility is that it started up here, went to here, probably went through and kept going a little bit, and then turned her back around. Nope. All 3 roots are covered. All 3 roots are covered, right? And you can't have one imaginary anyways, right? Okay? So, you know it turns around here, got to go through that point, and it's got to come back to it, and it can't cross the x-axis anywhere else, correct? Because there are no other zeros. We're good there? Okay? So you should be able to draw that sketch, right? Without knowing the equation? Alright, so now how do we find the equation? So y equals a, right, so I don't know what that value is, times what? X plus 2
X plus 6.
squared, or x plus 2 twice. And then what? X minus 4. Alright, how are we gonna find a? Plug in what? 16, 0, right? Your y-intercept. Which makes this a lot easier to figure out, right? So 16 equals a times what? Uh-oh. PEMDAS, what goes on in here? 2 squared. 4. Negative 4. Right? 0 minus 4, negative 4. Multiply. 16 equals negative 16a. A equals negative 1. You have to be able to do this without a calculator. This is not a big deal. Okay? So now what I got? Y equals negative 1 times x plus 2 squared times x minus 4. That's my equation that meets those requirements. But once again, what they say, standard form, so let's get as far as we can here. Can I do this first? We'll do it the opposite way this time. Do that one first. So leave the negative 1 out there. I'm going to do that at the end. What's x plus 2 times x plus 2? X squared plus 4x plus 4. Still have an x minus 4 in the end. Leave the negative 1 alone. Start double distributing with the x squared, right? Parenthesis, x cubed minus 4x squared. Then you gotta go with 4x, right? Plus 4x squared minus
16x
plus
4x minus
16. Still have a parenthesis around it. Because I still gotta distribute that negative 1. I'm gonna do what's inside the parenthesis first, combine my like terms. Y equals negative 1, x cubed. What happens to my 4x squared? Cancel. What about my x's? Negative 12x minus 16. Final step. Multiply by negative 1.
y equals negative x.
2 plus 12x plus 16. Yep.
Will you? Are you sure? Not too positive about that.